Greetings everyone. I am Bona Sikagarama, an applied statistician specializing in data analytics and research design. I'm here to help you master data analytics using Python. If you encounter any challenges or have any questions regarding this course, please don't hesitate to reach out. I am here to support you on every step of the way. Let us embark on this exciting journey of knowledge and exploration together. Thank you. In the previous session, we learned several online platforms that publish the datasets. We also learned how to search, download, and import online datasets to Python Jupyter Notebook. In session 6, we are going to learn how to rename the variables or columns and perform some basic visualizations. Renaming columns in a data frame is important for several reasons: clarity and readability. Original columns or original column names might be unclear. Renaming them makes the data frame easier to understand. Avoiding conflicts. If multiple data frames have similar or identical column names, renaming them avoids confusion and errors. Improving documentation. Renaming the variables or columns facilitates you to remember the variables in future. It also facilitates other future users to perform data analysis smoothly due to clarity of the variables they will be utilizing. This is the data frame we are going to import in a Python Jupyter Notebook. This is Excel. Close it. Search for Jupyter Notebook. The data frame is in the document named Session 6. Open this folder, Session 6. This is my data frame, table underscore results. So let us create the command window. File. Go to New, Python. Title. Okay. Import the library pandas. SPD. Run. So we will be importing other libraries due to their uses as we perform some analysis on the way. We import our data frame. Let us call it df data frame equal bring your pandas library to d.read Excel within the inverted commas here, include your location, the location of the data frame. Go to your folder, Session 6. This is my data frame. Go to right click and go to properties. Location. This is my location. Copy it. And paste it here. Then import the data frame. Go back to the folder. This is the data frame, table underscore results. Copy it. Go back to your Jupyter notebook. Paste it. Dot XLSX. So this is the extension of Excel. Double backslashes. Run. Then execute your data frame and limit it to 2 rows. Run. Okay. df.shape to examine the size of our data frame. It has got 66,081 rows and 66 variables or columns. We are going to rename some variables here. For instance, we have type of place of residence. This is urban rural. We have expenditures. We can also rename it. And then 1A1, this is gender or sex. B1A2, this is the relationship to the head of household. B1A3Y, this is age. Renaming the variables or columns. Okay. To rename the variables, we need to copy this data frame because we don't want to change the original data frame. Just say data frame 1, df1 equal to the original data frame df.copy. Run. Execute your new data frame df1 dot head 1 limited to 1 row. Okay, good. Now we are going to use df1 as our new data frame to rename type of place of residence, expenditures, B1A1, which is the gender, B1A2, relationship to the head of household, B1A3Y, H. You're going to rename it to other names. Okay. Bring your data frame dot rename columns equal create the dictionary in the odd variable, which is type of place of residence, copy it and paste it, rename it to urban rural, then bring another variable, which is expenditures, renamed it to let us say consumption. Then B1 A1 renamed it to vendor. B1 A2 renamed it to the relationship to the house, to the head of household, comma, B1A3Y, test it here, renamed it to, let's say, this is H. So within the dictionary, these are the old variables and the new variables. Now, for the dictionary, include the comma in case equal true, meaning that we are going to replace these old variables to the new variables. Run. Then execute your new data frame. Run. You can see we had type of place of residence here. The new variable is urban rural. We had expenditures. The new variable is consumption. Had B1A1, the new variable is gender. B1A2, the new variable is the relationship to the head of a household. And then B1A3Y, the new variable is H. Data visualization. Data visualizations, or data visualization. Okay. We are going to run the counts of the population by region. Counts of the population by region. Create the new variable AX equal SNS dot count plot in the bracket X equal bring your variable which is region then comma palette. Palette is for colors. Palette equal let's say rainbow. Palette is another argument for colors. Here no brackets, comma, and then another argument is data. Data, you bring your data frame. Then run. Okay, the message error here. Name SNS is not defined. As I told you before, other libraries, the libraries are not only limited to pandas. They are numerous. So you can import or install the libraries depending on their use during data analysis. So SNS is seaborne. Let us import seaborne. Import seaborne as SNS. Run. Run. So you can see our bar chart is big in size. It is big in size. And also the value labels, x-axis labels, are not clearly seen. So let us increase the width and reduce the height. Now, plot.rc params with the bracket figure dot figure size. This is not the bracket, it is co-brackets. Equal in the bracket 9, for instance, and 2. So 9 is the digit. It's the value for adjusting the width. And the second value, 2, is for adjusting the height. Run. Name plot is not defined. You can see we included another library, which is PLT, multi-plot library. So it tells you that we need to import this library, multi-plot. Go back. Now, it was not included before. As I told you, the libraries depend, importing or installing of libraries depend on the statistical function you are running or you are performing. Now, import matplotlib dot py plot as plt. Run. Then let us go back to our command. Run now. Run. Okay, you can see the width increased. You can now clearly see your value labels. Seat of Buiza, Southern Region, Western Region, Northern Region, Eastern Region. And the height also reduced. Okay. As you see this bar chart, the maximum is the Southern Region. The highest number of population, Southern Region. Next is Western Region. The third is here, Eastern Region. The fourth, you come back, Northern Region, and the last, the lowest, is the seat of Buiza. So you can see this bar chart is not user-friendly to some readers. So what do we do? Let us arrange the values in ascending Now, in descending order. So to arrange the values in descending order, to make the bar chart user-friendly to the readers. Here, in this command, we include another argument, order. Order, okay, let's bring it down here. Order equal within the brackets. The highest is southern region. Southern region, comma. The next is western region. Then the third is eastern region. The fourth is northern region. And the lowest is city of Buiza. Execute. You can see in ascending order. Okay. Then what is lacking here? The title is lacking. Value labels are lacking. Then what else? Count here is okay. X-axis label is region is okay. So what is lacking is the title and the value labels. Next, bring your matplotlib library dot title, because we are going to title our bar chart. Title. The counts of the population by region. C. So we have given it the title. Then value labels. Just say the text, added the text here in the value labels. For I in AX dot containers colon AX is your new created variable for the above command. It is the new created variable for this command, the command that runs the bar chart. So it is the new variable for this bar chart. AX dot bar underscore label. You are labeling the bar chart. I the values or the counts. Can it be the counts in, can it be the value labels in counts or percentages? So this is in counts. Run. You see now, the highest population is located is in the southern region, and the lowest in the city of Buza. As you can see, this value is at the y-axis limit, so it is not clearly seen. We need it to be within the y-axis limit, below the y-axis limit. So what do? You increase the y-axis limit. In your multi-plot library, dot y limit, y-lim, within the bracket and the brackets. Now, the limit starts from 0 to 15,000. You can see. Now, make it from 0 to 18,000 or to 19,000. 0 to 19,000. Run. Still it is a bit touching at the y-axis limit. Make it to be below. Let's say 0 to 19,500. So you can see now the bar chart is user friendly to the reader. So now here you can adjust the colors. You can adjust the colors here. Palette equal to rainbow. Make it, for instance, reds. Run. So you can see how it looks like. You can adjust the colors to, for instance, blues. Run. Autumn. Okay, let us consider this, the seasons. Autumn, winter, summer, and so on. So that is data visualization. So you will figure out more colors here for visualizing such kind of bar chart. You can visualize more. For instance, here in this command, you can add another argument for hatch. Hatch equal, let's say star. Run. So you can see how it looks like. Hatch equal to O. You can see how it keeps on changing. Hatch equal to, for instance, this slash. Run. So that is visualization. That's how we perform some basic visualizations. So this is a univariate analysis, the analysis of one variable, only a region. So let's say, let us run the count of the population by region and by gender. The count of the population by region and by sex. Now, here we have two variables, region and sex. So the command for region, you already have it above here. Just copy it. And paste it here. So we are going to add another variable, which is gender. So can you add another argument for who? Where is it is for any categorical variable. Any categorical variable. Now we have gender as our categorical variable. We have two variables here, region and gender. So if we run this, we are going to get another bar chart. Male, female, male. See? Now, you can see these bars are far below the y-axis limit. So let us make them approach the y-axis limit to make the bar chart look more clear. Okay, so it is just use this. Let me see here. It is 0 to 15,000. Mine here in this command, it is 0 to 19,000. So reduce it to 15,000. 0 to 15,000. You can see it's a bit. It is still a bit far. Make it to 13,000. 12 to 11,000. Okay, this is fine. This is okay. This is a two-way bar chart, two-way or two-variable bar chart. Province by sex, female, male. Then let us consider some quantitative variables and categorical variables. For instance, we want to examine the age distribution, area or place of residence, or age distribution by urban and rural. Age distribution by urban and rural, or by urban and rural. Bring your Seaborn library, SNS dot paste, plot. This is histogram plot within the bracket. Data equal df1. You bring your new data frame, then x equal bring your quantitative variable, which is age. Okay. Paste. Then KDE. This is kernel density function equal to true. Now another argument, which is who. This is for categorical variable urban rural. Run. To avoid this rubbish here, plt include plt.show. You can see how our plot looks like. X-axis for age, y-axis for counts. Okay. This is urban and this is rural. The figure shows us that the highest number of the population reside in rural areas. You can see here, and this is urban areas. Then another way of interpreting it, you can see the age distribution is positively skewed. The longest tail is to the right. There is a positive skewness. This positive skewness, you can see this curve. It is for rural, meaning that the age distribution or the age difference is higher in rural areas. Rural areas, there is a very high age difference. So for urban areas, it is approximately normal, approximately normally distributed. So the age difference is not high in urban areas. Okay, that is how you can interpret this kind of figure. We can also use expenditure and urban rural. Copy the same command here down. Where there is edge, replace edge by expenditures. It was renamed to consumption. So consumption and urban rural. The urban rural. Let us run and see. Fine. This is rural. And is this gray, something that kind? Urban is here. So the color the colors are not clearly seen. We can add another argument here for expressing, for identifying the colors. Blue and another color, for instance, let's say green. Done. Okay, as you see here, this is rural and this is urban. The highest population reside in rural areas and the lowest in urban areas. Then for consumption here, you can see for rural areas, the graph seems to be normally distributed, meaning that the consumption in rural areas does not differ. The difference in the consumption in urban areas is not high. But in rural areas, you can see this is positively skewed. There is a skewness. The highest or the longest tail is lying to the right, positively skewed, meaning that in urban areas, the difference in consumption is very high. There is a very high difference in the consumption. Okay. This is how we visualize data. These are some basic visualizations. Okay. Thank you. Make sure that you subscribe, like, and share. So subscribe so that you can be able to access the next tutorials. Thank you. Have a great time.